Segueing from our previous tutorial with if statements, we're going to talk about the else statement now. So, as I said before, in the previous tutorial, the code within the if statement is executed if the condition is true, if this statement here is true. Now, if it's false, we have the else statement. So let's write that. Else, it's written like this, else, colon, and your code indented as in the if statement. Let's say if it's not equal to hello or hi, we're going to say some sort of like curt reply with hey. Alright, so I changed the passerby speech to say nothing. So obviously it's not hello or hi anymore, and it's going to be, this condition is going to be false. So let's build this, and as you see, we got hey. So as you can see, else, any code within the else statement is printed out, which means the condition was false. Alright, and as with the if statement, indentation applies to the else statement. So let's make some new if statements right here. So let's delete everything here. Alright, let's say we have if 5 less than 7, oops, I forgot the shift, 5 less than 7. We're going to indent here. We forgot the colon. If, indent, if again, let's say 5 greater than 6. Then we indent again. Remember, in Python, we have to indent for each new statement. So this print I'm going to print out right now, I'm going to type right now, applies to the second if statement. So let's say we're going to write 5 greater than 6. And let's build that. And as you can see, nothing was printed out because the indentation we see here has no other conditions in it, no else statements. So first, it checks this, which is true. And since that's true, it checks this statement, which is false. And so there is no false, like nothing to do when it's false, so it's just left blank and there's no result printed. So in order to have a statement when it's false, we use else. So let's say I wrote else like this. And when this condition is not true, we want print 5 less than or equal to 6. And we're going to build this. And as you can see, we got the same result as before. That's because we didn't indent the else statement properly. So we have to have if and else statements with matching indentations. So let's do that right now. So let's indent this else to be paired up with this second if statement, and we do this here. Indent properly. As you can see, it looks orderly and it has a logical flow. So let's build this now. And as you can see, it printed this second line of code. It printed the second statement, as you can see here. That's because we indented properly. Moving on, we can also do this in a block of code. We can have several else statements. So let's say we have this whole thing right here, if, else, and then we have on the outside of that, this is just an example. You can do this with variables, you can do this with larger, more complex conditions, and so on. So say we have else here, and we're going to say, I don't know, print not true. This is just an example for the sake of the example. So let's change this to 5 greater than 7 now. And let's build that. So as you can see, the indentation matches, the indentation of the if statement matches the indentation of the else statement, as you can see here. So as you can, that pretty much concludes this tutorial. Tune in next time. Alright, let's use our conversation example from our previous tutorials. So we have the passerby speech. This time I modified it a little so it's equal to hi. And we have the previous if and else statements from before, but we just modified them a bit. So this time, if passerby speech equals hello, so if we're saying hello, we print out hi. And if he doesn't say hello, we'll just give a reply hey, like sort of casual. Alright, but here, in this case, it's neither one. It's not hello, it's not going to be hello, but we have another condition. We want to make another condition because we actually said something. So in this case, we're going to use what's called elif, the elif statement, which is basically, it's used when we have a condition that didn't pass, so it was false, but we want to check for another condition. So in this case, we have passerby speech equals hi. So as I put before, it says hi, and we're checking for this condition. Alright, hi, and when it says hi, we print hello. We don't want to sound like a parrot, so we say hello. Alright, and this is pretty much how it works. We have if, checks for if passerby speech equals hello. Since it's not, it goes on to the elif statement, which is hi, and that checks out, so it's going to print hello. For some reason, I don't know why it is giving me a syntax error. Just give me a sec. What am I forgetting? Hi, hello. Oh, I made a colon here. See? There you go. So as you can see, it printed out hello because the elif statement checked out. So from this example, we can see the following sort of structure of how if and elif are used together. So you have if, well, this is just some pseudocode, so don't mind it. It's not real code that will be built. So let's say condition, and then we have under that some code. Then we have if, elif, elif, condition, let's just say condition 2, let's call that condition 1, some code, then elif, condition 3, and some code, and then finally our else statement. Keep in mind that we're also using indentations here to match which pieces of code go with which conditions. Alright, else code. It is important to note here with these that else if statements should be mutually exclusive, which means that only one condition should evaluate the true within this block. So if we have, for example, let's do another example here. Let's erase all this. So we're going to have a variable called num equals 3. And then we're going to have if, let's do enter, if num greater than 1 and num less than 5, we print num. And then if we'll have an elif statement, elif, oh, forgot the colon, don't forget your colons in your conditions. Elif num greater than 2 and num less than 4, colon, and statement, let's say print num plus 1. Then we finally have our else statement, which is just else, and we print num minus 1. So let's build this. As you can see, we have 3. It'll never be num plus 1, even though this condition is actually true, because the condition before it is true. So it immediately finishes this condition and prints out our result. This just illustrates how elif statements should be mutually exclusive. So this should be some sort of other statement. Instead, this should be kind of fixed around, adjusted, so they're not true at the same time. Another important note is with if and elif statements is that you can also have nested if statements as we've seen before. However, it's sort of not recommended because things can get complicated, but you can use this at your own risk and to your own disposal. It's all up to you. So that concludes this tutorial. We hope to see you next time. To conclude this chapter, we're going to talk about the ternary operator. This operator is used when there is a decision to be made when assigning a value or to a variable. For example, we have passerby speech from our previous tutorials set to hello. And then we're going to have our response, let's say called me equals hi if, so we're writing the conditions in line along with the value, if passerby speech equals hello, don't forget the double equal sign, hello, or passerby speech equals hi, else hey. So what we did here, we're going to set this variable me to hi if passerby speech is equal to hello or if it's equal to hi. Otherwise, set it to hey. So let's print this out. So we're going to just do a simple print statement of me. And when we build it, I forgot the equal sign again. Don't forget the equal sign. It says hi. And if we wrote, for example, if it's nothing, then we'll get hey. So it kind of works as if condition statements, but in line along with the value. So this can also be done with numbers and other variables. So let's do a equals 3, a equals, and then after that we set a equal to 7 if 2 to the power of 3, 3 to the power of 2, that is better, is greater than 9. Else, otherwise, we get equals 14. And then we're going to print a out. So in this case, a is going to be 14 because 2 to the power of 3, 3 to the power of 2 is not greater than 9. In fact, it's just equal to 9. So we get 14. So if we change this to, for example, 3 to the power of 3, which is true, we'll get 7. So we basically reassigned a's value using the ternary operator. So to recap, ternary operator is basically assigning a value to a variable and using conditional statements like if and else and in line with the value itself in order to set it to a different value. And that concludes this chapter. Tune in next time for our next tutorial. In this chapter, we'll be talking about loops in Python. So what loops are basically blocks of code that are executed a number of times. So far, we'll be talking about for loops and while loops. And in the end, we'll be talking about break and continue statements. First, let's define what we're going to be seeing in for loops called range, the range function. What this is basically it defines sort of range of a loop to iterate through. So our prototype of range looks like this. Range, start, stop, and step. So start and stop are basically the actual range itself. And remember, it's inclusive. So if we had range 1 to 5, it's going to include 1 and go all the way to 4, which I'll demonstrate later on. The step is the amount of increments to take in each iteration. So, for example, if we have 1 to 5 and the step is 2, it'll go from 1, 3, and then it will stop because 4 doesn't reach that number in 2 steps. Or let's do actually a better one. Let's say 0 to 4. With iteration of 2, it'll go 0, 2, and then eventually 4. So let's actually demonstrate how this works. So you'll see better you'll see it better in iteration, in actual illustration. So as you can see in Sublime Text, it actually did it for me by autofilling. Let's say this is I, and we'll just erase all this garbage. How about we do range from 1 to 10, and then we're going to print I. Don't forget your colon after the for loop statement. This is what it looks like basically. So we have for any letter variable. I like to use I, like in most programming languages we use I. Use in, the in keyword, and then here's our range function, and then here's our actual range of numbers. Alright, so let's print I. We'll build this, and as you can see below, let me just go up, you can see here 1, 2, all the way to 9. And as you can see, it is inclusive, so it includes 1, but it finished at n minus 1. So we can say the range is from the beginning to n minus 1, as you can see here. So our stopping point was 10, but here we actually see it's 9, so that's n minus 1. So let's add a step to this. Let's say 2. It's going to increment in numbers of 2. So let's build that. And as you can see, it goes 1, 3, 5, 7, 9 in increments of 2. And let's actually, so that's basically it for that. And let's just do another example with other numbers. Let's say 0 to 12 with increments of 3. Just so you just get the point of this whole, to get the gist of this whole, how for loops. So as you can see, in increments of 3 went 0, 3, 6, 9. And since, remember, it's inclusive, so the final number is not included itself because that's how these work. Now if we did, for example, 13 here, you would get 12. So in for loops, with a range, keep in mind that if you actually want this final stop number, be sure to do one number above it, as you see in other programming languages. Like traditionally we use like int I, for example, whatever, and then it's, for example, up to 10. That's like this, basically what we did. This is equivalent to this. Let's say step 1. You don't actually have to include the 1. This default is 1. And then we just have I++. This is basically how it's done in other programming languages, and this is how it's above is how it's done in Python. So what I wrote down here is basically this up here. And if you want actually, sorry, this should be 10. If you want actually to go up to 10, you do this. And I forgot the 0 here. This is just illustrating how it all works. You do less than or equal to 10. And so you have, this is basically this. And that pretty much concludes our tutorial on for loops. Please tune in next time. So let's continue talking about loops. In this tutorial, we're just going to show some more advanced examples. And then in the next one, we'll apply what we learned. So let's say we have this string given here. It says string traversal. We are going to iterate through this using a loop. So here we have, I typed this ahead of time just to save some time. So here we have a normal for loop with the range function as we saw before. And this time, our range is actually going to be the length of the string. What we use is the length function, which is just ln, and inside the argument here is the actual string itself, which we called string. And then we're going to print string with square brackets and I. So kind of like, it looks kind of like an array, since a string is an array of characters. So let's build that. And as you can see, it looped and printed out the actual string. So keeping this kind of method in mind, we also have another way of doing this using characters for the loop iterations instead of using the actual range function. So let's do that. Let's erase this whole thing, and we're going to make a new for loop. So for I, actually for char in string. So we're saying now loop through the characters in the string, and then we're going to print char. And let's build that. And as you can see, you got the same result. This is a simpler way of writing what we just had before. Instead of writing, let me just undo all this, instead of writing this. So you have this cleaned up, neat, explanatory for loop instead of what we had before, which is kind of complicated, but it's all up to you to choose what you're going to use. You can also do, another thing we have in for loops is you can have nested for loops. So let's write an example out. So let's say we have for I in range 3. As you can see, this writing of loops is simpler than in other programming languages because Python works with indentation and colons like in the statements. So let's do, whoops, I forgot the n. Alright, so for j range 2, whoops, for range 2, and then we're going to print. So in Sublime Text, it automatically indents for you. Be sure to keep your indents. Be sure to keep your lines of code indented where needed. Alright, let's build that. As you can see, this is our result. Alright, so next time we're going to actually apply all the stuff, everything that we learned in a sort of bigger example, so you can see kind of how for loops can be used in real-life applications. And we hope to see you next time. So now we're going to actually apply everything we learned from for loops to a real-life application. In this example, we're going to print out a 10 by 10 multiplication table. So let's start off by making our first main for loop. So we're going to do for in I in range. We want a range of 10, as in the 10 by 10 table. So we're going to do 1 to 11. Remember, the stop point is n minus 1, so 11 minus 1 is 10. Then we're going to add that colon. Indent. Print. I'll explain in a moment what this is. I'm just going to write it out first. So curly brace, quote, actually, quote, less than 3, curly brace, and then we're going to have a line in there, separator. Alright, and then we're going to have dot format I. Alright, so what we're going to do here actually is this is going to print out from 1 to 10 for our indication of the first row. What this does right here, it aligns 3 places to the left. And we need to make this display on one line. So first let me print this out. As you can see here, print kind of makes a new line after each iteration of printing. So what we need to do is make everything in line. What we're going to do, at least in Python 3, we need to do this. This is how I do it. I'm sure there are multiple ways to do it. Just right after this format function, we do comma, and then end equals blank string. So let's build that and print. As you can see, we have everything is printed in line. And you'll see as we move on, you'll start seeing the actual table itself. So moving on, let's make our nested loop now. We're making the rows and columns now with this new for loop inside the nested loop, I mean. So this is also going to be a range of 10 because we're doing a 10 by 10 table. So 1 to 11, same as before, colon, and then we're going to print. We're going to do a similar thing as before, but this time we're going to have alignment with 4 places to the right. So let's write that out. So open your quotes, begin your curly braces, colon, greater than 4, and then close it again. Close your curly braces, and then outside the quote, dot format, and then we're going to do I times j. You can space it out to make it more neat. You don't have to though. And then again, once again, we need everything in line, so end equals empty string. And let's print that out. As you can see, we have a we're starting to see the table it's not spaced correctly and aligned properly. It's not aligned properly, so we're gonna fix that right now. So on the next line, after that print, we need an if statement aligned with the nested for loop, so indented with the same level as the for loop, as you can see here. Let's put another space so it looks more readable. Alright, if I equals 1, let's space that out, 1, colon, we're going to print something else out. What we're going to print, you'll see in a second. So print, let's see, new line, open your curly brace, colon, hashtag. Now in my case, it's going to be 44 here, but depending on this window size, it can be different. But you'll see how this looks at the end. So we have print, dot format, and then we're going to have open our format function with empty. It's going to be empty. And don't forget end at the end because we want it all in line once again. Alright, so what this did, it prints 44 hashtags and it aligns them to the center and occupies this many spaces. Alright, and then after this, let's print that out. And there's an error here because I'm not done yet. Just hold on one second. Let me just finish this off with print, open your quotes. So let's just review our code right here. Oh, and of course, I believe I forgot something. Hold on one second. Oh, that's right. I forgot the caret symbol with inside this. So be sure to write it like this. We'll explain later in future tutorials how this works. So, as you can see here, we finally got our table. Those hashtags filled up 44 spaces. On my screen, it's 44. On your screen, it may be different depending on your window size. So as you can see here, we have the one row and then all the way to 10, and we have 10 by 10. And so that pretty much solves that example, and that's pretty much it. Alright, we're going to talk about while loops now. So what a while loop is, unlike a for loop, it's used when we have a repeating block of code in cases where we usually don't know the exact number of repetitions. And the repetitions stop when a certain condition is fulfilled. So let's write some sample code out. So we're going to have here variable called condition equals 10, right? And then we're going to write while condition not equal to 0. So regardless of the value condition, we're just iterating, we're repeating a block of code when condition is not 0. And we're going to print, oh, don't forget your colons, and then print condition. And then afterwards, we're going to iterate condition equals condition minus 1. So let's print that out. So what this did, basically, is print condition counting down from 10 to 1. And then when it reached 0, it stops completely. So without knowing in advance the amount of iterations to take, we subtracted 1 from condition. So we did 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and so on. And then to the end, to 0. And when 0, it stopped. And what while can be used for is used for infinite looping. So let's do this. Let's do while, remove that, while true. And what this is going to do, print infinite, how do you spell it? Alright, and we're going to print this out. And as you see, it keeps on going forever. So while can be used for making infinite loops? It's used very often in practice, but how would you exactly stop this? It's stopped by the break statement, which we'll be talking about next time. To conclude this chapter, we're going to discuss the break and the continue statements. First, let's start off with break. Okay, so what break is going to do, it is used when we want to stop an execution of a loop. So from the previous tutorial, we had this infinite loop where it printed an infinite amount of times. And when we use break, for example, let's write out break, and then we're going to print. As you can see, it only printed out once. So after printing, it broke the loop and it finished, and it only printed infinite once. And that's pretty much how break works. So if you want to stop a loop, just use break. Like you could have a condition, another condition within the while loop, and after that condition, it breaks. So let's talk about continue now. So we're going to erase that. And if you want to skip a certain step in the execution of a loop, we use continue. This command, what it does, it skips all the commands that come after continue all the way to the end of the loop. So let's write, and it's used often in for loops. So let's write for, it kind of filled it out already when you press tab in Sublime Text, but don't worry about that. Let's just write out what we need. So we're going to do 1 to 11, and then we're going to have if I equals 5, colon, we're going to do continue. So what this does, it skips print, and of course at the end we're going to have print. What this is going to do is it's going to skip where I equals 5. So let's do that. Let's print that out. Let's build that, and let's see our result. As you can see, there's no 5 here because when we use continue on the condition if I equals 5, excuse me, we don't print it out. We just skip it. And so that's pretty much break and continue. That's pretty much it. We hope to see you next time. Welcome back. In this chapter, we'll be talking about functions in Python. We'll be learning where to use functions, how to define them, and how to pass parameters. And we'll also conclude this chapter with the lambda functions. To start off, we're going to talk about something which is called decomposition. So what that is basically segmenting the code into smaller parts, mostly for easier reading and maintenance. And we'll basically be using this for functions, which are portions of code that are set out to do a certain task or to return a certain result. So let's start off by defining our first function right here. So let's go here. And so in Python, we start off with def, which is sort of a built-in kind of function as you saw here. Def, and then we're going to have our name of a function. Let's just call it function for now. In Sublime Text, you know you did it right, but when you have different colored text for the name of the function. And then you add parentheses, and then you add a colon. And then you indent, and then you add whatever code this function is supposed to carry out, what portion of the tasks this function is going to do. So for example, this is going to print, this is our first function. Okay, so this function is sort of code within the code, so it's a portion of the full program that does just printing out this statement. So and now we can call this function. So we call, if you're familiar with other programming languages, later on we can reuse this function by calling it in the following way. So you type the name of the function in Sublime Text. We have autofill, so we're going to function, parentheses, and that's pretty much it. And then when we build this, as you can see, we have our predefined function, and then we call it, and that code is read by the interpreter, and you see your results here. So what we also have with functions is returning results. This is another service purpose of functions. And what this does, instead of having basically this print inside the function, we actually have a return value, which is another purpose of functions, to give a return value of some sort of code that's to be carried out, that is to be read and interpreted. So let's do this. Let's define another function, def, and the name of this function, let's say it's called, I don't know, returning, parentheses, and then colon, and then inside that we're going to have return a string, for example, and let's say I am a result. Okay, so in this case, since we have return, it won't print out. This returns a value, but you have to print it out manually. So let's do this. So we have print, and inside that we're going to have returning. As you can see, it autofills for us. So returning, don't forget your parentheses. So as you can see here, returning, and there you go. And a good habit to have when programming is that you store the result, you store return functions with the return value to a variable of some sort. So let's say we have a variable called result equals to, and we're going to call returning with parentheses, don't forget, and then we print it out. We print out the variable result. As you can see, it's the same thing, but this time it looks more orderly and clean instead of having it the way we had it before, which is like function within a function with like double parentheses, and that's kind of confusing. So like this, it's pretty clean. And moving on, we also have something interesting in Python, which is we can return multiple values. So let's make another function. So def. And we're going to say we're going to call this one, I don't know, let's say multival. Open our parentheses, colon. And then we're going to say, so return, return. And then let's say we have two values, a string called this is a result. And then to separate them, we have a comma. Let me fix the string. We have a comma, and it's separated by the other value. So as you can see here, we have two values, and they're separated by the comma. And notice that this function is printed out in parentheses, which you're going to see right now. So let's do this. We're just going to do it the messy way. So let's do print multival, and let's build that. As you can see, it's sort of, here's our first return value, and here's our second. And so that's it. This is how they're separated. And then later we'll learn how to actually extract these values. And that pretty much concludes our introduction to functions. Please tune in next time. All right, moving on to sort of piggyback off of our last tutorial, we're going to talk about parameters within functions. So we learned that how to define a function and call it and return a value from the function. So what we're going to do now is pass an argument to a function so that we can perform a certain manipulation on that argument, or parameter as it's called here. So let's write our first example. Define function called parameters. And in this function, we're going to have our first parameter. Let's just call it a. Right? And then we're just going to print a. So, and then when we call the function, so it's called parameters, we need to define a. So let's say a, for example, is a string called this is a parameter. As you can see, this string was passed into the function and manipulated somehow. And in this case, it was manipulated through print. Alright, so we can also pass more than one argument, and let's make a new function now. Let's just erase this. Define it as add, for example, and then we're going to have two functions called a and b. Excuse me, two parameters inside the function called a and b. A little tongue-tied today. So let's do c equals a plus b. And then we're going to return c. And so when we want to, so this time let's do the right way, the proper way, and say we have a result variable, result equals add, and don't forget we need two new parameters now. So let's say 12, and to separate them, we do comma and then 5. So a is equal to 12 and b is equal to 5. And then, so we have that result, and then we're going to print this result. Print result. And let's build that. whoops, I made a mistake here. Oh, I forgot the colon again, of course, silly me. Don't forget those colons. So, of course, 17. We can also do this with strings. So let's do that. Instead of having numbers, let's have 1, and then this B, A is 1, and B is word. And then that sort of adds them together in one string. And that pretty much concludes that part, and let's move on to the next part. So this part is for default variables, default parameters, excuse me. What these are basically the default values of a parameter defined in a function if that parameter is not manipulated. So let's call the default param. That's our function. And then we have the parameters A, B, C. And it's gonna be written in the following way. So in these parentheses, where our default parameter is, you write B equals our default value 4, and C equals our default value 5. This is just an example, so it could be anything, whatever your heart content, sort of. All right. So keep in mind that parameters with default values should be put last. So as you can see here, A, we wouldn't have like B before A, and so on, stuff like that. So here we go. So we have our default values defined. So let's continue. And then we're going to have return A plus B plus C. That's XC. All right. So let's see. Let's store that to a result again. And then we're going to do default param. And let's say A is equal to 3. And as you see here, we are not going to define these with commas and then a value. So let's do that. Build. Oh, forgot to print. Whoops, my bad. Print. And then result. As you can see, it added 3 plus 4 plus 5, which is 12. So the default parameters were passed into the function, and which is printed out. And so keep in mind here, as you can see, functions in Python pass by value. So, and we'll also talk later about passing by reference, which is more complicated, but will be done later. But in general, functions pass by default by value. So literally, we took 4 and we passed it. All right, moving on. Let's talk about scope. Scope is like the range of use of a parameter inside a function. So within a function, the scope of a parameter is within the function itself. So for example, let's have a new function here called scope. So scope call with a parameter a, and let's say a equals a plus 1. This is just some examples, so don't worry about specifics. So we're going to print a, lowercase a, and then return a. So scope, then we're going to call scope, and then a is going to be equal to 5. As you can see, it did everything for us. Now, if we wanted to call a, we wouldn't be able to call a outside this because a is only defined inside the function. So let's say if we tried to print a, why is my caps lock on? A. As you can see, it gives us an error. A is not defined. So remember, parameters in the function are only within the scope of the function. And now moving on, speaking of scope, actually, we have something we can use nested functions, like we had nested loops before, like a loop within a loop. We also have functions within functions. And the scope of these functions, of nested functions, are only within the function that's outside. So let's define a new function called outer, with the parameter a again, colon, and then inside that function we're going to define another function called nested, and it's going to have its own parameter b, and then we're going to define it as return b equals a. And then to keep in line with our indentation, we have the actual code in the first outer function. So a is going to call nested and return value with the parameter a, and then it's going to return a. Now this looks kind of confusing, but basically the thing to see here is just nested can only be used with an outer, and an outer utilizes nested as a part of its code. So let's do this. Let's print this out. So print outer with number, I don't know, 4, let's say. Print, and I forgot something. Hold on a sec. I forgot the semicolon. So here we have to use, with nested loops, you're going to have to use semicolons. So let's make that more clean. And just give me 1 second. Oh, my bad. I made a mistake. I read wrong. It's supposed to be multiplies. All right, so 16. So as you can see, 4 times 4 is 16. So as you can see here, outer used the function nested, which took argument for a, and it was 4, which b was also 4. So as you can see, it did everything as it should have done. All right. So the whole concept of nested functions can be used for aggregating more functions as a result and get with another function as well. So this might be a little complicated, so let me just, yeah, let's do it now. Let's just get it over with. So let's say we have a function called f, and with a parameter a, and then we're going to have inside that function called g, and then it's going to have, so kind of a similar situation as before. Okay, so what we're going to do now, we're going to define both parameters in the following way. So let's first make our function again, return a times b. So don't forget your semicolon if you're using a function within a function. So actually here, there might be an error, but hold on, we'll see in a sec. Return g. All right, so let's actually remove that. Maybe that was a typo. So we're going to print now. So we're going to call the function, the main function, the outer function, and then we're going to have 2 arguments in parentheses. So 2 parentheses, groups of parentheses after the other. So first argument a is 5, and the second one is 2. So let's build this. As you can see, we got 10. So we actually made the second argument, the nested function, we defined it, excuse me. So we defined it, and that's done in the following way. So we have the first function, the outer function, and then the nested function can be defined like this. And you could also do this again in aggregation. So let's add another function here inside f. So we're going to, inside a g actually, excuse me, we're going to have define, so we're having a loop within a loop within a loop. So it's kind of like loopception right here. So h, c, and then we're going to have just a semicolon. And then we're going to have, after that, we're going to have return a times b times c. And as you can see here, we have that. So we're going to then, after that, we're going to return h. And then outside of that, we're going to return g. So we have 3 arguments now. And you just add the parentheses on. Let's do that. As you can see, we got 5 times 2 times 30. So that pretty much concludes this section. Tune in next time. Alright, continuing with functions, we're going to talk about recursive functions now. So what these are known for, they're known for their top-down approach to problem solving. Recursive functions basically break down a problem into more subproblems and then solves them. So what recursive basically means is that a function calling itself. So it uses itself over and over again. And what we need in these is a base case and a recursive call. And I'm going to, right now, I'm going to just define a function, a recursive function, so you can actually see how it works. So let's do this. So it's going to be for factorials. So this will demonstrate how to calculate a factorial with the help of a recursive function. So let's say we have our argument or parameter called n, and first we need the base case, which is if n equals 1, then we return value 1, which helps us exit the recursion going on. Return 1. Else we're gonna do return n equals factorial. Oh, and wait, no, there shouldn't be equal sign there. That was my mistake. N times factorial n minus 1. So as you can see, based on this code, if n isn't 1, it's going to do this return statement multiple times. So it's going to do n times function itself over and over again. So this basically divides the calculations into subproblems. So let's actually demonstrate this right now. So let's call our function. So let's say print factorial. Let's say we're going to do the factorial of, I don't know, let's give us a number. Let's say the factorial of 5. And then we're going to build that. And I made a mistake. I should have wrote, let me just see here, forgot the colon again. And as you can see, 120, which is correct. So as you can see here, it just does what it says. The factorial does 1 times, it goes from 1 to times 2, actually goes from 5, 4, 3, 2, and all the way to 1, which then finishes. So it does 5 times 4 times 3 times 1. And that's basically how factorials work, as you probably already know. So let's actually look at other kinds of, there's actually a couple types of recursion. We have regular recursion, and we also have tail recursion. So let's first demonstrate regular recursion. So def sum, this function is called sum now with the parameter n, with colon, of course. Alright, so if n equals 1, we're going to, as before, return 1. And then else, let's see, we're going to do like before in the factorial problem, return n plus sum n minus 1. So we're doing, for example, if it was 5, we do 5 plus 4 plus 3 plus 2 plus 1. And this is basically regular recursion. And tail conversion, for example, we're going to do tail sum now, tail underscore sum parameter. What this does, you're going to see in the it's going to do the following. So we'll have the following parameters. N, this one's going to be called accumulator equals the default value is 0. So inside this function, if n equals 0, we're going to return the accumulator, and then else, then we're going to return, if it's not 0, we're going to return, you're going to use recursion here, function within the same function within itself, n minus 1, with the arguments in accumulator plus n. So let's just build and check everything's okay. So everything's good. Alright, now let's print them. Print sum, and with the argument 10, and then print tail sum with the argument same as 10. So 10. Alright, print. As you can see here, why did it give me none? So let me just check my code. Accumulator. So here we go. Sum. So here, as you can see, sum is a predefined function. Now I'm just checking why it gave me none. Let me just check my code again. Diff if equals 0, accumulator. That should be good. Yes. Alright, so oh, of course, the indentation, I believe, and something else. Oh, the return should be no. Oh, right. Silly me, I forgot to return on the other part of this statement. Silly me. As you can see, we got the same result. So sorry for the delay, I just kind of had a sort of brain fart. So what we did here is basically we did the same thing but in two different ways. The first way is just regular recursion. And the second way we had tail recursion, where we actually used a repeating parameter, as you see here with this accumulator. And so that pretty much, I hope you kind of got the concept of recursion through these examples. We hope you tune in next time. Welcome back. So to conclude this chapter, we're going to talk about lambda functions, or the lambda operator. So what we're going to do, basically, I did here already. I made it like a sort of inline function. So our function call is going to use f, actually. So let's see how this works. So I already typed it out, so let's just call f with our arguments 2 and 3. And we're going to build that. As you see, we got 5. So lambda is just a nameless function. Since we have the name for the variable outside, it's called anonymous, or just a nameless function. And you have the parameters, then you have a colon, and then you have whatever code is to be executed, which is to be interpreted. And so that's how that works pretty much in Python. So this is probably similar to the arrow operator that in like, for example, C. But what to take away from here is that you can make an inline function. And this also applies to nested functions, and we'll show that right now. So let's erase all this. Alright, so we have f again, and then we're going to do lambda. As you can see, it's highlighted in blue and italicized, which means you did it right. So let's have lambda with the parameter a. Inside that we have another lambda function, or it's called the lambda operator, called b, and then lambda c. It's xc. So we have a function within a function within a function again. So, and after that we're going to have a times b times c. So this is a simpler way of writing of example before, where we had three nested functions, function within a function within a function. So this is pretty much an easier way to write that example from before. So let's do this. Print. And then again, once again, we're defining parameters in the nested functions. So let's do that right now. So open our parentheses like this, 5, 3, and then 2. So, and then we're going to build that, and we got 30. So 5 times 3 times 2. So 15 times 2, which is 30. All right. And then we're also going to do another example with the following. It's just pretty simple stuff. You just write lambda for your function, and as I said already, so no need to repeat myself. Alright, so let's just write another example so you kind of just grasp this stuff. Alright, so lambda c, lambda a, then comma for the argument, and then side is another function, lambda. Let's call it, I don't know, lambda d. And then inside that we have c, oops, actually no parentheses, c times, and we're actually using our order of precedence from before, so check out our previous tutorials for that. And let's do remainder d. Alright, let's just clean this up a little. Okay, there you go. Alright, now let's call this. Let's see, so f, we're using f, so 2, and then 4, 3. So the parentheses are following the order of the nested functions from left to right. So the first argument, c, is 2. The second one, a, is 4. And then 3 is the next one. And then after that, we have 11. So let's build that. As you can see, we got 3. So we got 2 times 7 remainder. Wait, no, whatever. You kind of get it here. So there you go. And that's pretty much just illustrates lambda operators, or lambda functions as they're called. So what the takeaway from this is that they're not exactly the same as lambdas in other programming languages, but the whole concept is used together with something we'll actually learn later, which are filter, map, and reduce concepts. And that pretty much concludes this chapter. So see you next time. Hello everyone. In this chapter, we'll be talking about exceptions and how to handle them. We'll learn about what exceptions are and how to basically handle such exceptions. I keep repeating myself with handling exceptions and errors in Python. And then on the end, we'll also learn how to create we'll learn how to create our own exceptions in Python. So to start off, we'll be defining what an exception is exactly. So what it is basically an error that occurs when a program, during its execution, is run into a situation that is not defined. So that's kind of like a kind of textbook answer. So let's just demonstrate what that looks like. So let's print the following. Print 5 divided by 0. Well, obviously that's undefined because anything divided by 0 is undefined. So let's build that. Control B. Alright, so here we go. And here's the exception. Zero division error, division by 0. So as you know, like I just said, I keep repeating myself that this is an exception and it is undefined because dividing by 0 is undefined. So that's basically this. It's zero division error. And then we also have that, if you remember, we worked with, from our previous tutorial, you can watch that too, about working with file management. We also have the following error. If we have want to open a file that doesn't exist, so let's say open, and the file is called, I don't know, let's just call it file, just random, and then we want to see in read mode. But what's going to happen is the following. You get the following file not found error. So that's another error. So we can this also occurs when we want to convert. We also have another error where when we want to convert a string into an integer. So let's do the following. We have int, and then we have 1.2. And then B, and as you can see, value error because 1.2 isn't actually an integer. It is, it's a floating point number, or with a decimal point after. There's a number after the decimal point. All right. Now, if we type out the two following lines, so let's do that right now. So let's say A equals A equals 5 divided by 0. And then we say print after error. So let's say we have that. Let's do this. As you can see, it'll identify actually where the error occurred. So as you can see here, it says traceback most recent call as blah blah blah, line 2. It says where the error occurred. So and it identifies which error actually occurred. So now that we've introduced ourselves to exceptions and errors, we'll try how to learn them and to avoid such situations with these errors. But keep in mind that these errors do not happen very often, but a good programmer will make sure they're handled and dealt with beforehand. And that pretty much concludes this tutorial. See you next time. So now let's talk about actually handling exceptions. So if you have some suspicious code that may raise an exception, you can defend your program by placing the suspicious code in a try block. So we're going to start off with try, and then you add a colon. So actually, let's start off with our actual suspicious code. So let's say that from the example from before, a equals 5 divided by 0, right? Okay, so we open the try block. And then after the try, we include an except statement, followed by the block of code which handles the problem as elegantly as possible. So actually, I should be writing this as follows. So first we start off with try, then we put our suspicious code, don't forget to indent, suspicious code within the try block. So here's our suspicious code. And then, and then after that, we do an except statement. So except, how do you spell except? Except, we'll call it exception. And then so in the older version, in version 2 of Python, we have the syntax would look like this. Exception comma E with a colon, and then you print, and then you do the whatever your code, whatever code you want to execute if the exception occurs. So we want to print what exception occurs if there is an exception, if there's an error. So as you can see, it says invalid error syntax. So let's do it in this version, in version 3.5, which I'm using in Sublime Text 3. You have to use as. So let's do that right now. As you can see, it says division by 0. Now we can also specify the type of exception to be thrown. Now this is being called throwing an exception. So you throw the exception. For example, let's do the following. So let's delete all this. And then we're going to say n equals int. So we're typecasting to int input. And then we want to prompt the user to enter an integer. And then we're gonna, this might be a suspicious code because what if the user enters a character of some sort and not an integer? Well, we're gonna say, okay, so let's try executing this code with keeping in mind that a value error can occur. So let's say value error. And then, so this time you don't have to define a variable, because last time we defined basically any exception can occur. But this time we are looking specifically for a value error. So if we expect an integer but we don't get an integer, it'll say print, we're going to say, hey, this is an integer. That is not an integer. And remember, we're working with the data input from one of our previous tutorials, from the data input tutorial. So you're going to have to build, since we're using input this time, we need to communicate with the console. So what we're going to do, we're going to go over to Sublime Reply, REPL, and then run current file. So let's say I write 1 in text. As you can see, that's not an integer. Okay, so moving on. We'll also do an example right now with multiple accepts. So we're going to type out the following code. All right, give me a sec. Let me just write that as code. So let's say sum equals 0. And then, so we have a couple things going on. We're going to try to open a file. And when you open a file, you should it's good practice to try and throw the exception if there's no file available. It's good because in case you're doing something and the file is missing or removed, you can say something like, your file, we don't have this file stored on the machine, or it's not found. So you can just say something like, you use an exception. So what we're going to do with this code, we're going to basically, so let me just write it out. So for number in file, so we have a for loop, and then indent, and then we're going to say sum. We're going to accumulate a sum of 1 plus 0, 1.0 divided by integer, so number. Oops, I did. There we go. Wait. Oh, whoops. We want to typecast number, because remember in files it's actually it's a character, so we want, or a string, part of a string, so we need to typecast it to an integer. All right, so we're taking this, we're commuting the sum of numbers inside of 1 divided by whatever numbers in the file, stored in the file. So we're gonna print the sum. All right, so here's our code, and now we're gonna have a couple except statements. So except 0 division error. Now in Sublime Text, it's not autofilling for this part, but when you type it out, here, let's try actually. No, it's not autofilling, so let's just type it out, division. 0 division error. Okay, so we're saying, okay, we'll be expecting a 0 division error possibly inside this in this code. So let's respond, be on the lookout for it. So let's say number in file equal to 0. And then we're going to have another one that says except, and an IO error. This is another type of error that's going to say, okay, so the file does not exist. File, let's just say DNE, just to shorten our typing. All right, so let's build this. As you can see, oh, there's a mistake here. Hold on a sec. Line 6, syntax error, invalid syntax. Okay, there's an invalid syntax error. So, oh, of course, forgot the colon again. IO error, forgot another colon, so don't forget your colons, kids. Alright, so file DNE, because the file's not there to begin with. And you can't do this, you can't try the 0 division error, you can't check for it because, well, there's no file. So, it's considered good practice to give us more information about the error included, so that's why when you have excepts, you should also print out whatever happened to tell the user or the programmer to tell us what happened. And we also have one more thing. It's called the finally block. This is executed regardless, this block of code is executed regardless of whether or not there is an exception. So we're going to add to this code a finally statement, a finally block, excuse me. And then what we're going to do, we're going to say we want the sum anyway from this code we just did. And then we're going to, if there was a 0 of some sort or something, we're just going to close the file anyway, just for safe measure. So let's do that. And let's see what's, okay. So as you can see, there was no file to close, but it still gave us 0 anyway. So see, file says name error, file is not defined, and therefore we couldn't close it. But anyway, since there was an error, it still gave us sum because we said print out sum, and as you can see from the beginning, sum is still 0. And that pretty much concludes this part, this section. Tune in next time. So now let's talk about throwing an exception. So even if your code doesn't really have an exception to be like an expected exception or error, we can throw one if we actually need one. So what we do, we raise the statement, and this is done with the actual, in the following way, let's just say. I'll just skip to the code itself. So let's say a equals 1. There's obviously no problem here. So we're going to say def, and then so we're going to define raise exception, and it's going to say a as the parameter. So in this exception, we're raising an exception, so we're going to say if the type of a is not equal to the type of character a, then we're going to say raise, here's the raise word keyword, now value error. This is not a string. So what we're saying now is if a isn't a character or actually string type, then we're going to say, well, it's a value error that's wrong, raise the value error because we want a string So, alright, so let's actually, and then, okay, since we have this error, we're throwing this exception, I mean, we're also going to try, we gotta try the code now. So we're gonna try raising the exception, so try. So actually, we kind of made a function right here. It's actually a function if you're familiar with functions from last time, so we defined it. This is the name of the function. And then there's a raise, the raise keyword inside that function. So this function is going to check for this value error. So we're going to try doing the function raise exception, as you can see, and then with our variable a. And then after that we have except, and then we have value error. Whoops, I forgot the space. Value error. See, it autofills for me. All right, so actually it's supposed to be except. My bad, not exception. So let's do this. So except value error as e colon, and then print e. So we're going to say, okay, so we're going to try doing this, running this function, and then we're going to print out what happened if there was an exception. So let's do this. As you can see, it says this is not a string because so this error actually worked. But let's say this is actually a string A. So let's do that. As you can see, everything checks out. So basically, our code works. So we're going to do that. This is not a string. So if we pass a string instead of integer, then we won't get an exception as I just showed you. But so another way to test a program instead of using raise, we have the assert statement. This statement, when encountered, causes the expression to be evaluated, where if the result is false, then basically an exception is raised. So let's write an example. Just erase all of this. So this time we're using, it looks like we're going to have, so it's called assert. So as you can see, it's highlighted, so it's a keyword. Alright, so we're going to define a new function called def. We're going to say test case. And then we're going to have two parameters, a and b. You can space them out, just to clean it up. So let's say assert a less than b. A is greater than b. So what we did, we basically, it's like we did everything in line, as you can see with this. So let's do this now. So we have try, and then we're going to run this function because it might be suspicious, as I said, so quote unquote suspicious code. So we're going to have test case with 2 and 1 as a parameter. So a equals 2 and b equals 1. And then we're going to say except, not exception, except, and then assertion error. So assertion we are using, that has its own type of error exception, so as e, and then print, whoops, I forgot the enter, as e, as print, and then, okay, so here we go. Let's build this. As you can see, there's a syntax error. Oh, forgot the colon. As e, forgot the colon there too. Alright, there you go. A is greater than b. So we asserted that if this doesn't occur, if this occurs actually, we're going to say a is greater than b. So that's basically it. So assert will assert a sort of exception, what that happens. So if we reverse this around, whoops, this keyboard's kind of weird. As you can see, nothing happened because this checks out. But this, if this doesn't check out, we're going to say a is greater than b. And that pretty much concludes this section. We hope to see you in the next chapter.